An environmentalist wants to determine the relationship between the number of fires, here in thousands, and the number of acres burned in hundreds of thousands. Based on the data below, compute the value of the correlation coefficient for the relationship between these two variables. So we've got x, y. I'm going to show two methods for computing the correlation coefficient. One will use the formula and the calculator. That's the first method I'll show. And then the other method I'll show just using the calculator by itself. A much shorter approach, but we'll see. Okay, so method one, formula in the calculator. The formula for the correlation coefficient, we can look that up in our form. Whoa. Sorry, I didn't mean to do that. We can look that up on our formula sheet. Oh, here it is right here. Chapter 10, correlation and regression. The formula for the correlation coefficient is here. It's a lengthy formula. All right, so let's write it down. I'll try to remember it. R equals, I forgot it already. Yeah, there we go. N times, do I need a parenthesis there? Times the sum of xy minus the sum of x times the sum of y over, I believe that's a square root there. Yep. Square root of, in brackets, n times the sum of x squared minus the sum of x squared, right? Minus the sum of x squared, new bracket, and the same thing with y. N times the sum of y squared minus the sum of y squared. To the back. Yep. Let me close this bracket. Okay, so we see our x values here, our y values here. In order to, so you can do this using a table. I'll write this out and then I'm going to erase it. So we've got our x values and our y values, right? And we need the sum of the x's, so I'll add these up. We need the sum of the y's, so I'll add those up. I need x squared, so I square each of the x values and add that up. Square each of the y values, add those up. Then I need xy. I multiply x times y, get that here, and then I add all of those up. If I was doing this all by hand, this is how I would do it, right? But I'm not doing this all by hand. I'm not going to do that. I'm going to try to be a little smarter about it. So I'm going to use my calculator, right? I'm going to go to Stat, Edit, and I'm going to enter my x values in column L1. I'm going to enter my y values in column L2. I don't know why there's a line there, but 72, 74, 61, 55, 85, 65, 54, 45. Enter my y values in column L2, the associated y values, right? 49, 88, 48, sorry, 59, 48, yeah, 21, 22, 55, 16, 32, 13. Let's make sure I have everything right here. Let's see. Whoops, 72, 59, 74, 48, 61, 21, 55, 22, 85, 55, 65, 65, 16, yep. 54, 32, and 45, 13. Perfect. Now look at the niceness that I am about to do. I go to Stat, because I want to do a calculation. And I go to two variable stats because I've got an x value and a y value. Two variables. Hit enter. And look at all the information that I get. I get the mean of the x values, right? I get the sum of x, 511. So let's write that. The sum of x is 511. I got that. What else do I have? I have the standard deviation of x. I don't need those standard deviations. Let's go down some. Wait a minute. Did I miss something? Did I miss the sum of x squared? I did miss the sum of x squareds. I have 33797. They tell me n is 8. I know n is 8 because those are the pairs. I have 8 pairs. 1, 2, 3, 4, 5, 6, 7, 8. Let's see what else we get. I get the sample mean of the y's. I get the sum of y. That's 266. I'm going to get the sum of y squared, which is 11,184. 11184. See, I got this, I got that, I got this. I just need the sum of xy. And would you look at that, going all the way down, I get the sum of xy, 18319. So there's no need to do all those calculations on the table if you use 2 variable stats in your calculator. And now at this point, I'm just substituting all of these values that I have into the calculator here. So I have n, which is 8, times the sum of xy. That's 18319. Let me just make sure that's right. Okay, yeah. Minus the sum of x, 511, times the sum of y, 266. That's my numerator. Denominator. So in the first bracket, I have n, which is 8, times the sum of x squared, which is 33797, minus the sum of x squared, minus 511 squared. That's my first bracket. And then I have n again, times the sum of y squared, 11184, minus the sum of y, 266, squared. I'm going to compute my numerator and denominator separately, just to make it easier. X times 18319 minus 511 times 266, 10626. And my denominator, I'll do it in pieces. The square root of 8 times 33797 minus 511 squared. It's my first one. Let's just calculate that. I'll use 4 decimal places. 96.2029. And I'm multiplying that by this piece. You can do this all in one step if you'd like, but I don't want you to make any mistakes with that process, because one mistake can foil up this whole problem. And I hope I'm not making any now. 136.8064. Okay, let's divide these. 10626 divided by 96.2029 times 136.8064. Close parentheses, enter 0.807. That's my correlation coefficient. Now let's see, this other approach now is purely going to be using the calculator. Let's see if we get the same result. Okay, here we go. Okay, to use this approach, I'm also going to enter stat edit. I'm also going to enter my values here, right? My x values in L1, my y values in L2. But now, what I'm going to do is I'm going to get a little tricky. I know if I do a test, the linear regression t-test, what that's going to do that's gonna calculate the line of linear regression, the linear regression, right? It's gonna calculate the line of best fit, the least squares line, for this data if it was plotted on a scatter plot. So I hit enter. L1, my X values, L2, my Y values, the frequencies are all 1. I don't really know what my null and my alternative hypothesis is going to be, so I'm just going to leave that alone and go to calculate. Gives me the t-test value, my p-value, degrees of freedom. But if I keep going down, it gives me R. Just like that, 0.807, which is exactly what I got when I did my calculation. So using the calculator, we also get R is 0.807. Either way, you'll get there. Either way, you'll get there. Okay?